Okay, it's 12:30. Let's begin here. Last regular day of class. First of all, just remember there are online course evaluations available for you to do. So far, only 5 of 10 of you have done a course evaluation yet. Please don't wait till the last day of class, or last day that you can, I should say, to do those course evaluations. If you're waiting to see what your final grade is in this course before you actually do the course evaluation, please note that I cannot guarantee that the final grades will be done before your last day that you can do your course evaluation. So just get it done now. Well, not right now in class, but later today. So today we will talk about some additional items that I just couldn't necessarily fit in anywhere else in the R portion of the course. We will not talk about the ggplot2 stuff, but of course you have my lecture notes available for that. I do recommend that you take some time over break to read them and try some of that stuff out. It's a different way to approach plotting. Today we will also review for the final. Are there any questions? Okay, so we have these additional items, and we're going to actually do first 2 additional items, which are not in the additional items handout here, or lecture notes. I thought of these after I had already posted the lecture notes to the web. So the first one corresponds to something that, for those of you who are in my Stat 810 class, you heard me mention very, very briefly, and that is something called S3 and S4. Okay, remember that the R statistical software package uses a syntax that's very, very, very similar to the S programming language. There have been a number of different versions of the S programming language. S version 3 came out in the late 1980s. S version 4 came out about 1999 or 2000. Okay, so when I say S3 and S4, I'm talking about the different versions of the S programming language. Now, when R was first developed, it was mimicking the S version 3. Shortly thereafter, it allowed S version 4 functionality inside of it. S version 3 and S version 4 are very, very similar. As you might imagine, S version 4 has some benefits to using it. However, S version 4 really hasn't been adopted by the masses of our users out there. Most stick to S version 3, and that's what we've been basically doing throughout the semester so far, or the R portion, was just talking about S version 3. I like S version 3 better than S version 4. The 2 R packages that I'm a co-author on are based upon S version 3. Now, as I said, there's not really much difference between S3 and S4. But there's going to be one difference I want to bring up, and I would imagine that for most of you, this is all you really need to know about the differences between the 2. So that's what I'm going to focus that on here. Okay. So with S version 3, let's say I had a list, and we'll call it set 1, or let's call it mod.fit instead. And inside this list, if I want to access what are called the components of it, of course, what I need to do is do stuff like this: mod.fit $, whatever that component name is. That's it. If I want to see the names of all the items inside this list, I say names mod.fit. Okay. Now, S version 4, the main thing that you need to know about it is that you can still have lists. The components inside the lists are called slots instead of components. And let's say I have a list that's based upon the S4 structure called mod.fit. If I want to access components of, if I want to access slots in that list, instead of using a $, I use an @ symbol. If I want to see the names of all the slots inside this list, instead of saying names, I have to say slot names, and then put mod.fit inside there. Okay. That's really, for most users, the main difference that you need to know. That's it. If you want to know more about S3, S4, as you might imagine, there's a number of different resources available. One in particular is Hadley Whitcomb's advanced R book that he recently published, and there's actually an online version available. So, for example, here's from Hadley's website. He talks about S4 right there. Okay? Any questions? Let's continue talking about lists. So my second main thing that I want to talk about that's not in the notes already is, let's say that I estimate a regression model to that GPA data set once again, and I put the results into mod.fit. I'm working with just S3 again. And as we saw, if I do names mod.fit, I have that. I have all the components of the list. Mod.fit $ coefficients. Oops, is how I access components, access the individual components. There is another way that you can access these components. I can use two left square brackets. I put the number of the component inside, such as, notice the first one is coefficients, and then I use two right brackets, and I get exactly the same thing. If I look at the second component, I get all the residuals out. This is not a very descriptive way. I don't think it's a very good way to access parts of a list. Most people don't do this. But I bring this up for a few different reasons. First of all, there are some people who do this. I think it's poor syntax, but you will sometimes see this. Another thing is that, let's say, for some reason you actually created a list yourself. You can use the list function to do that. We've seen that before. And you wanted to be able to easily access it, access components of the list. Maybe like in a for loop. Let's say you do for I in 1 colon 10. Well, you can, since you have a numerical way to access components of the list, you could just simply put like mod.fit, left bracket, I, right bracket, and you can easily access every component in that list. Okay? Now, also, there are times where, and this is bad programming, where some people will not actually put names to the components of their list. And so the only way that you can then access it is through using this numbering system. Again, it doesn't happen very often, but it happens often enough. I think it's important to at least mention in this 2 minutes in class. Any questions? Okay, now let's go back into the notes. So something that's important to understand in terms of how R operates is to understand what's called the search path. Basically what the search path is a vector that shows you where R looks for objects. Specifically where this is most of interest is where R looks for particular kinds of objects, functions. So let's look at the following scenario. Let's say that I've downloaded from CRAN 2 packages, MRCD, bin group. These are the ones I'm co-authors on. And I use the library function to say, hey, let's use the objects that are inside this package. And when I issue the command search, this will then return to me the search path. This is, again, where R then looks for objects when you give a specific name. So let's say that I have a particular function in MRCV that's called, we'll just give it a generic name, myfunc. Okay, that's I have one object, it's a function, it's called my.func. And I want to use it. But what if I happen to also have, not just in MRCV, but in bin group, the function called my.func? How does R then decide which function, the one in bin group or MRCV, it will execute? That is when the search path is very important. So the first thing on the search path is this thing that basically stands for global environment. What this basically means is stuff that you have in R's database itself. If you remember, very first day that we look at, we talked about R, if you did the ls parentheses n parentheses command, you see a list of all the objects in R's database. Do the same thing with the objects function too. That's what this global environment means. And so R is going to actually look in that global environment first for this function my.func. Next, if it doesn't find it, it goes to the bin group package. So that's the my.func that will be executed, not the one from MRCV. And so you can see that if you're using simple function names, if you have many packages ready to go, you can get into trouble by executing essentially the wrong function if you don't understand what the search path means. Okay. Notice how the base package is the very last place where R looks for a function or object. Are there any questions? Search path is very important. Okay, next. Now, R, by default, sets a particular folder or directory on your computer where it will automatically look for files that you want to read into it or files that you want to write out outside of R. And so far, we haven't really talked about this default folder. I never bother with it myself. And so if we wanted to read in an actual data file, what we typically did was like use read.cd, or in this case read.table, and we put the full, C:// give the full directory address to find it. Instead, what you could do is just simply give the file name and then set a working directory yourself, working folder, that R will automatically look first for whatever file you're looking for. So simply, if I do set WD, WD for working directory, this is where I can put in that potentially a very long directory structure. So the advantage of using set WD, and I often do, is that you can specify, if you have like a lot of different read.cvs or read.tables, you don't want to have to put the long directory structure out every single time. And so that's why I often will set WD at the very beginning of most of my programs that are complex. Now you can actually read in files directly from the internet. In fact, you can read .html pages or any other kind of web page that's out there. That's more complex than what we want to get into. And so instead what I want to do is just simply show you, well, suppose you have a nice data file that's already out there at a particular web address that you know about, such as, for example, the GPA data itself. I use that in my textbook that I wrote, and it's at that particular web address right there. And so if I wanted to, instead of downloading it to my computer and then using read.table to read it in, I can do it. It'll actually look more simply by actually, for read.table for file, actually putting in the web address. And just do it directly. Let's talk about debugging. So very often when you write a computer, any kind of computer program, It's not going to work the first time, and you have to figure out, well, how can I fix it? And we've talked about techniques like when you're writing your own function that you can put print. You can use the print function. You can use the cat function inside of a function to print off the results, so you have an idea of what's going on inside. Also, we've talked about how you can set particular values for a function or even a loop outside of the loop, and then just execute every line in that function or every line in that loop to try to figure out what's going on wrong. Well, sometimes another way of doing this that can be helpful is to use what's called the traceback function, and it simply traces back in the order of the code that you're running to let you know, well, where did the problem occur. And so, for example, here I just simply use qnorm to find a quantile from a normal distribution. I use it correctly. I use pnorm. I use it correctly to find a probability from a normal distribution. And then I decide to use qnorm again, and guess what? I forgot something. I forgot p. And I do have an error message printed, but in a more complicated setting where maybe you're executing a lot of lines of code, you can execute and also trace back, and that will try to trace back where the error occurred. Now, it just so happens when you use trace back with knitr and licks, it's not very useful. But if you were to execute this code on your own, you will see outside of licks and do it directly in R, you will see some helpful information printed. Next, we talked about a matrix structure in R. Of course, a matrix structure is two-dimensional. You have a row and you have a column. And so we can store information inside of a matrix structure. Well, we can generalize this. A matrix is actually a special case of what's called an array. So maybe you have a three-dimensional structure, a four-dimensional structure where you want to store information inside of it. The way to do that in R is to use the array function. One place where this can be helpful is when you're dealing with contingency tables. So for example, I'm going to skip down to here to this output. Here I have a three-dimensional contingency table, meaning I'm summarizing the counts to, in this case, a particular survey that asks people, what's your political party affiliation, Democrat or Republican? What's your political ideology? VL, very liberal. SL, slightly liberal. M for moderate. SC for slightly conservative. BC for very conservative. And then lastly, we have information on gender. Okay? So it's a three-dimensional representation of the observed survey counts. So for example, 44 people were Democrats, very liberal, and female. Now to store that kind of stuff in R, we can use the array function. It works a very similar manner as a matrix, as you might expect, since a matrix is a special case of an array. So I'm going to create an object called c.table. That stands for contingency table. I could have called it something else if I wanted to. And I use array. And just like what we saw with the matrix function, the first argument is data. And I combine together my cell counts of that contingency table. Here, you have to be very careful, again, about the order that you go in. There's no way that you can change this. The order is this. You have to enter in the first column first. So notice how this corresponds to these values right there. And then you enter in the second column. And that's all within what people often refer to as the first strata or first layer of the contingency table. And then we can go to the second layer and so on. Unfortunately, knitr didn't really handle some of the formatting very well, so you can see that things are kind of going off the page there. Then, let's say the dimension of your contingency table, 5 rows, 2 columns and 2 strata. Then, I briefly mentioned this argument last time for matrix. It's called dim names. Dim name stands for dimension names. What do you want to call the rows? What do you want to call the columns? What do you want to call the strata? And the way to actually enter in these names is to actually form a list. So I say a list. The first, and you have to go in this order, the rows correspond to ideology. And I put in the corresponding values for those 5 rows. Next, you have to put in the columns, put in the 2 names, and then lastly, gender. So, if I want to then access particular parts of the contingency table or the array, I can do it as you would expect, just like with a matrix. I can specify a row number, a column number, and a strata number. So, for example, row 1, column 1, strata 1, remember those 44? Well, I just enter them in there, separated by columns, and I get my 44 back. Next, first of all, make sure I'm talking about everything that I need to here. Okay. So next, for those of you who may have experience with Linux, you're probably used to doing something called a pipe. Where basically what a pipe is that you're chaining commands together at a command prompt so that the results for one command go directly into the next command, go directly into the next command, and so on. I have no use for piping myself, but I know some people who are in computer science who really like it, and they do this all the time, especially, at least one place where I have experience with it is with respect to using like a command prompt in Linux. And so, maybe about 2 years ago, a new package in R was written. I think it's pronounced Ritter. I've never heard anybody actually say it out loud. I just read about it. We'll call it Ritter. Allows you to essentially use this kind of syntax. So if you by chance are already used to it, you might like this. Here's how it works. I think it's kind of interesting. I have these simplistic examples just to show you how it works. Not that someone would actually ever want to do it exactly the way I'm doing it here. Okay, so you have to actually download this package first. And then you can say library Ritter to use it. And let's say to begin with here, I want to find the 0.025 and 0.975 quantiles from a standard normal. We know those values to be negative 1.96 and positive 1.96. And so what R returns to you is a vector that has those 2 elements in it. But let's say I want to immediately turn around and use these 2 elements in a new function. You can do this by using % greater %. This comes from the Ritter package. And what that means is pipe, using a Linux terminology, pipe the results on the left into the function on the right. And so by default, what R then will assume is that the very first argument that you would have for P norm, which would be Q equal, will get these results. And so if I use P norm and simply just say mean equals 0, est equal 1, Q is assumed to be the results from the previous function. Look when I get back out, 0.025 and 0.975. Let's look at another example. Let's take my serial data set. So I read it in, I fix sugar, fat, and sodium. And then I use the subset function that we just talked about last time, where I say, in my serial data set, I want just those cereals corresponding to shelf 1, and I only want sugar and fat to be pulled out. So what I get then is a data frame that looks like this. Okay, so that's the results. And I want to pipe these results in to a new function. That function is, hey, let's estimate a regression model. Would one really want to do this here? No, but it shows you how this works. So I'm going to use sugar as the response, fat as the explanatory variable. But remember, I had just told you that whenever I use this percent greater than percent, it says put the results into the first argument of that next function. Well, this first argument for LM has to be, is, if you look at the syntax in terms of the help, is formula. So that's not going to work for me exactly. So instead, the package allows you to do this. If you don't want the results to go into the first argument, you can instead use a period as an argument value anywhere in that function call, and that's where the results will be piped in. So notice for my data equal period, that's going to give me my data frame that has 10 rows and 2 columns that I just got from subset. And thus the model will be fit. Lastly, let's do exactly the same subset. But this time I'm going to use %, $%. What that will allow me to do is to, if my results that I get from that left-hand side function, if that ends up being a list, then it will allow me to work with the individual components of that list. And so remember, a data frame is a special case of a list. So when I execute this subset code, I get 2 components, sugar, fat. And so I can then call these components by name then in the function I'm piping this stuff into, and I can find the correlation between simply sugar and fat. Perhaps some people who come from a different programming environment might find this to be more user-friendly. I don't know. I guess I don't. That's not how I learned how to program. Anyway, any questions? At the very least, hopefully you agree with me. It's kind of interesting. And lastly here, something that can be very useful is that let's say that you have some data. Maybe you have some data observed for a particular random variable that's essentially continuous. And you would like to group that data in kind of an automatic manner. How can you do that? Well, you can use the cut function. So let's say that I simply simulate 100 observations from a normal distribution, standard normal. And when I say cut, first component is your data. The second argument is what's your grouping structure. So let's say I want to go from -3 to -2 to -1 and so on. So my first group is going to be -3 to -2. And I'm going to put that in an object called groups. So if I come over here, and if I do groups, you can see the very first observation, which was -0.025, falls into my -1 to 0 group. The next observation falls in the 0-1 group, and so on. And you can go ahead and summarize this further. Suppose I use the table function with it, which just simply finds a table of counts. You can see that 40 times I had an observation between -1 and 0. And as you would expect with a standard normal, you're going to have more values in the middle than on the edges. Okay. It can be a very useful function. Are there any questions? Yes.
If there is some observation which doesn't fall into these groups, then what happens with that?
Well, that's a good question. Let's try it out. I'm not for sure off the top of my head. There we go. NA. Okay. So notice what I did if you didn't see. I just changed the break so that I knew there would be some observations outside of -2, and that's what happened.
What will happen to the table part of it?
I think you'll, well, let's just see. In that case, it just skips it. There might be a way. Yeah, there we go. There is an argument for use NA, and you could set it probably something that will give you like a warning message. Okay. Any other questions?
Could you put like a 5.1 statement in there to break it up instead of by integers?
You could put, yeah, I mean, what you could do is something like this: sequence from equal -3 to equal 3 by equal 0.1. Let's make this a lot bigger so that I actually have some counts that fall into every column. And there you go. Any other questions?
Where would we use something
Well, we often, as I like to say, since I've written a book on categorical data analysis, we live in a categorical world. We like to put stuff into categories to help make sense of it. That's when somebody would want to do this. Imagine age groups. You want to put people in age groups 15 to 19, 20 to 25, or whatever. Other questions? Okay, then that concludes then the material for this course. Let's go ahead and start talking about the final. So the final exam is not tomorrow, but 1 week from tomorrow, Friday, December 16th, from 7:30 to 9:30 a.m. in this room. I find it odd how UNL schedules finals. We don't ever meet on a Friday. We never meet at 7:30 a.m. Why are we having a final at 7:30 a.m. on a Friday? Well, for some reason, Nebraska says, hey, we need to leave open, I guess, Friday afternoon for anybody who still, for some reason, can't make a final or something like that. So if you notice, there are no finals scheduled on Friday afternoons. Interestingly, well, in case you don't know this, I got my undergraduate degree from UNO, University of Nebraska-Omaha. And we, at that time, and still do, and they still do now, do not follow that same system, despite being in the University of Nebraska system. And we just simply say, or they just simply say, you take, if you have, let's say, a 12:30 p.m. class on a Tuesday or Thursday, your final is either going to be on Tuesday or Thursday at 12:30 p.m. One of the 2 days. It's so much easier. So I wonder how many people have actually missed their final because they were totally thrown off by this weird scheduling system. But, oh well. So it's over the R material except for the knitr stuff. So no knitr. Except for maybe in an extra credit problem. The test structure itself, there's 100 points. It is finalized unless I find a typo or something. And this is what it looks like. Problem number 1 has 30 points. It's 3 parts. And you're going to have to write some R code for it, as you might expect. Problem number 2 is 24 points. 4 parts. Again, you're going to have to write some R code for it. Problem number 3 is 12 points. It's a short answer question where really no R code is needed. Problem number 4 is 34 points. 5 short answer questions that are not necessarily connected in any way. You may or may not need to write our code. And lastly, there is one 3-point extra credit problem. Now, obviously, I have broken up the R portion into certain sections. There is at least one problem from every section, or at least one part of a problem from every section. So don't just say, screw it, I'm not going to study regression. Chris isn't going to ask me any questions from the regression section. Don't do that. You'll regret it. Now, the test has the same structure as the last test in terms of when we start class, I will say, hey, go to the graded materials webpage of the course website. You can download a Word file that contains the test. You download it to your computer, and this is where you put all your answers. I will also pass out a paper copy of the exam, just in case you might find this to be useful, so that you don't, since obviously you have limited space on your computer screen, it might be useful to actually view the problem separately, so you don't have to flip back and forth, let's say, between RStudio and your Word file and so on, to see what the problem's asking. So I will give you the paper copy as well. But no answers should be written on the paper copy. Or you can write answers, but I'm not going to grade them. Also, what I've done, similar to last time, is on Blackboard, I've set up a final exam link here. So this is under Test Quiz. I click on that and click on Continue. You will turn in your electronic version of the test by browsing to your computer, attaching the file, and then not save all answers, but save and submit. And similar to last time, what I will do is up on the projection screen here, I will have some information that will help you see, did I receive your file or not? Obviously, you got to be very careful here what you turn in. Make sure you actually are turning in the last version of the test that you are working on. Not, let's say, maybe you downloaded the file that had the empty test, then you decided to copy and paste it so that, and call it something else, and that's where you actually put all your answers in, and then you accidentally turned in the blank copy. Don't do that. Make sure you turn in the right copy of the exam. Of course, make sure you back up stuff, too, when you're doing the test, because obviously computers can have issues. So the exam, as stated on the syllabus, is 30% of your grade. As I think I said before, I do not scale tests at all. You know, the grade that you get is the grade that you earn. So I will not do any scaling. On the exam itself, make sure that you show your work. And typically what that will mean is that you need to put all your R code and output that's used to answer a problem. So if a particular problem asks you for a numerical answer and you only give a simple number, I'm not going to give you full credit unless I see your corresponding work that was used to get to that point. This is also obviously very helpful in terms of partial credit when needed if you did get the numerical answer wrong. Let's see now. So our first exam, we did not take the test in this room, so this would be the first time that you're using the computers at these desks. Please make sure that you can log into the computers. Just simply use your UNL AD account, or in other words, your Blackboard ID. Make sure you know where R is located on these computers. Make sure you're just comfortable with using like RStudio on these computers. Tin is on these computers, but unlike on mine, it's an earlier version of tin, and unlike when I use tin in class, I highlight, I come up here to the corresponding icon, and I click on that, and it sends the code over to R. That link does not work on these computers, unfortunately. I haven't been able to get information technology services to fix it, unfortunately. So, but you can still copy and paste manually as needed from tin to R. Again, if a particular problem asks you to write out an equation, like maybe I asked you to write out the estimated regression model, you're welcome to use the equation editor in Word. But if you don't, and you say, and instead you decide to actually write it out in Word, such as, let's say, y hat is equal to, you put in the corresponding values times x. I will not take off if you put y hat there. If you only put y there, I will take off because you're not acknowledging the fact that this is actually an estimated quantity. So you can use the equation editor if you want, and type y with the caret sign on top of it, or you can just write it out in words. This is a closed book, closed note test. However, again, you have access to all my R programs on my website. You do not have access to any of my lecture notes. You do not have access to any of the assignments on the website. During the test, please make sure you keep your eyes on your own computer. I know, especially in this tiered class structure, it's a little bit easier to maybe see around the computers, to see the person in front of you. Please just don't do that. Keep your eyes on your own computer. Do not communicate with anybody electronically inside or outside of class. And also remember, I will be able to see what's on your computer screen using this right here. Okay, so I will know if you are accessing something that you're not supposed to be doing. You can use the R help as well. No Google searches. Just my website, what's available there in terms of the R programs, the R help that comes with R, and that's it. Are there any questions about the structure of the exam? Okay, let's review some of the material then. So we begin with a brief introduction to what R was. We talked about some basics, like it's important for you to understand the correct terminology. What is an object? What is a function? What is an assignment in R's terminology? That's when you go less than dash, or you could use an equal sign too. So x gets, let's say maybe the value of 2. I'm making an assignment. Understand what an argument is. Well, that's one of what we often more easily think of as an option, let's say, that's in a function call. But R formally calls these as arguments. Understand like a data frame, a list, components of a list. Make sure you understand how to write a function. Maybe I ask you to calculate, write a function that calculates the coefficient of variation. Not for sure what the coefficient of variation is. That's okay. I would give it to you on the exam. And the sample coefficient of correlation is, I believe, S divided by X bar. Standard deviation divided by the sample mean. For some reason right now, I'm going to think I think sometimes it's the reverse, but I'm 95% confident that's actually the standard deviation divided by the mean rather than the opposite. The main thing, though, again, is I would give you what the formula is, and you would need to actually calculate it. Write a function that does it. Maybe even as practice, that would be good. Can you write a function that calculates the coefficient of variation? When you write a function, what gets returned to the user. Remember, it's the very last thing that's in the function itself. So that's how you return things to a user. You can return things as a data frame. You can return it as a vector. You can return it as a list. There's a variety of different options. Also in this section, we talked about program editors. I would just maybe ask you a question about the basics, such as, well, why is using a program editor like TIN or RStudio better than simply using the editor that comes in R? Well, what would be an answer? Well, Chris says it's better. For example, syntax highlighting. And whenever you write a large program, if you didn't have syntax highlighting, that would be rough. I say that from experience because I used to use SAS at a time when there was no syntax highlighting. It wasn't until SAS version 7, which came out in about 1999, I think, that had syntax highlighting. Okay, then we went into the regression section. And we talked about data management, some of the basics, how to read in a file, how to export information into a file, how to access just a portion of the data set, how to access, in terms of the rows or the columns. A lot of logical comparisons are made to help do that. We talked about using the plot function, how to make your plot look pretty with using various options or arguments in plot. Then you can use various functions to add stuff to a plot, such as the curve function. Then we talked about estimating a regression model. And we can use the LM function for that. Understanding that syntax there will help set you up for success with more complex modeling functions that you will encounter in other courses, because people typically try to write functions in the same way. Now, the results from LM come back to you as a list format, so you need to make sure you know, as we discussed earlier, how to access particular components of that list, how to summarize. Remember the summary function. Inside the LM function, we talked about how, suppose you have more than one explanatory variable. How do you include it? What's the syntax? How do you include a square term, for example? How to include interactions. And then eventually this led us to a big thing, which was the whole concept of object-oriented programming. Every object in R has a class. And that class is very important, especially when you execute generic functions. Make sure you know why that is important. It's one of the big things, I think I even said it then, this is one of the big things to get out of this, is to understand the object-oriented nature of R. I know when I was first starting to learn at the time S+, I didn't understand that for a couple years. And once I did, then everything started to click about, okay, that's why I can do this. Or that's why the behavior is different. No one ever told me that. No one ever taught me that. And so eventually I figured it out. And it made things a lot easier. Also, how do you view function code? Just simply type the function name. And that's one of the advantages of using R. Nothing's hidden. You can actually, if you need to, execute, get a function and execute all the lines of that function line by line to see exactly what happens. In fact, I have one of my PhD students right now doing that to try to figure out how a particular function is working. Then we started talking about the finer points of graphics. So we focused on just the graphics package. We did a lot more stuff with plot. we talk about how to add a legend, how to add text, how to use the identify function. We also spent a lot of time talking about PAR. PAR stands for graphics parameters, and this controls various things corresponding to your plot. One thing in particular is, well, suppose you want a 2x2 grid of plots in a graphics window. Well, you could use the MF row argument in PAR to get that done. We talked about mathematical and Greek expressions or letters. How do you get those on the plot? We also talked about some more complex things to do. Let's say if you want, and this was with the serial data set, you did this with the NFL data set too, and that is, well, if I want to, let's say, color code the plotting points by another variable in my data set, how can I do that? Then we had single variable plots, such as histograms, box plots, dot plots. Make sure you understand how to do those. And so that was graphics. Then we started talking about control structures. And what that basically means is it controls what's executed in your program or how often it is executed in your program. And so we talked about if-else and if. What's the difference between those two functions? When should one be used over the other? How do you use them? Then for looping structures, we talked about for. And we can also put this in a looping structure too, the apply function. The key is that you should try to avoid doing loops if at all possible by taking advantage of how R performs its calculations most often using vectors. So like if I want a quantile from a normal if I want two quantiles from a normal distribution, is it easier to use two calls to QNorm or one call? Well, it's one call to QNorm, and then just put a vector of the corresponding probabilities in QNorm. And then we also talked about, this all led up to then Monte Carlo simulation. I could ask you to do a small Monte Carlo simulation in the test. Make sure you understand the concepts that we talked about, like the true confidence level. These are all fundamental concepts for at least those of you who are going on for a master's and PhD in statistics. This is an essential concept of research. It's an essential concept to understand so that you know why or how particular statistical methods work. Then next, summarizing and managing data. Our data is not often in the correct format that we need in order to analyze it. So we looked at some tools to get it in the correct format or to extract certain information from a data set that we could then follow up to analyze. And we talked about functions such as merge or reshape, aggregate. We talked about those kinds of functions to make sure you're very familiar with how to use them. Next, we spent a little bit of time talking about matrix algebra. Obviously know the matrix function, how to use it. Like the by row argument. The difference between vectors and matrices in the context of what R thinks of them as. Then the basics of how to do the inverse of a matrix, how to find a transpose of a matrix. And then lastly, we today talked about additional items. I don't think that's necessarily for me to review that because we just did it today. But I could ask you a short answer question such as, what's the difference between S3 and S4? Make sure you know what, I also have on here, make sure you understand what recycling is. I think we talked about that, at least in the matrix algebra section. Of course, all my videos from our course are available online, so perhaps you could do some binge watching on Thursday night and just sit around and watch them all. You could. So that will give you a nice way to review the material as needed. If you have any questions, obviously before the exam, please feel free to post them to the listserv. I do not have my normal office hours during finals week because schedules are quite different, but if you post something to the listserv, I'll respond to it, or send me an email if you want to meet with me for some reason. With respect to grades then, so what I will do is I will obviously grade all the finals, and then once I get done with that and decide on overall course grades, I will put a message on a listserv saying, hey, I'm done. Here's a summary of the grades. And what I would do is post your actual grades to Blackboard so that you can see them. Before class, what I did was I posted all the grades that I have for everyone to Blackboard, and also what I would calculate as your current grade in this course, taking into account how everything's done via the syllabus or what's listed on the syllabus. So at the very least, before you take the final, take a look at what your current grade is that's shown on Blackboard. Also, make sure that I got all the grades entered in correct. Obviously, I couldn't make an error when I type in your grade, so make sure I got it right. So after I have all the finals graded, made decisions about letter grades, I, again, will post that information to Blackboard so you can go ahead and take a look at it there. Do note that I do go by what the syllabus says, so if you get like a 89.4, that's like a B+. It's not an A-, it's not an A, it's not an A+. My syllabus says it's a B+. So, okay, so that's all I have specifically to say about the exam. Are there any questions? Okay then. Well, thank you very much for taking the course. I know some of you didn't really have a choice, but thank you anyway. I think this was a fun course to teach, and I hope to make improvements on it next time. So, okay, that's it for today.